Jai Hind, I am Madhup Agrawal. Today's our topic is quicksort. This is very important topic related to data structure. So first we understand what is quicksort. So quicksort is a sorting technique. Sorting means arranging data in ascending or descending order by using the divide and conquer approach. This quicksort follows the divide and conquer approach to sort the data. So how to sort the data using quicksort, we will understand. Before that, what is divide? In divide, first pick the pivot element. We choose a element around that all the elements are sorted accordingly. So we will see later. In divide, first pick the pivot element. After that, partition or arrange the array into two sub arrays such that each element in the left sub array is less than or equal to the pivot element and each element in the right sub array is larger than the pivot element. So means first position the pivot element such that the left element of the pivot are less than the pivot or equal to the pivot and the right elements are greater than the pivot element, and we will repeat this process in the. And then divide and conquer means recursively sort two subarray with the quicksort, means left portion and right portion sort using the same approach as before. Now we will see by example, or if this is the array, so choose the pivot at the proper position. This is left subarray and right subarray. So the process fundamental to the quicksort algorithm is to partition. How to partition? Means how to place the pivot element at its proper location. We can choose pivot element randomly or fix this is the we choose this for the pivot and place this element as a its proper position, or we choose first element or random element. We will see later. So the process fundamental to the quicksort algorithm is the partition. The way partition works is by first selecting a pivot. How to select the pivot? We select the first element as a pivot. We can choose the last element as pivot, any random element, middle element as pivot. In this example, we will choose the last element as pivot and see later. So as the example, if this is our data 9 minus 3 5 2 6 8 minus 6 1 and 3, then let us select the last element means 3 as a pivot element. Now position this 3 at its proper position such that left element are less than equal to the pivot element means 3 and right subarray element are greater than the pivot element. So place this pivot element at its proper position. This is the partitioning. This is the fundamental partitioning. So we will see how to place this pivot element at its proper position. Now we create two sublists. The left list contain value less than the pivot and the right sublist contain value greater than the sublist. This is less than or equal to. Now we then find the pivot for the sublist. This is sublist, this is sublist, left sublist, right sublist. So find the pivot for the sublist and repeat the partition process. The pivot for the left sublist is 1. Same funda. We are choosing the last element as pivot. So for the sublist, we must choose the last element as pivot. We cannot choose now first element as pivot. In the whole scenario, we must select the same pivot element last. If we are choosing last, then for subarray choosing last element as pivot. If we are choosing first, then choose the first element as pivot. And the pivot for the right subarray is the last, that is this is subarray and the last element of the subarray is 6. So we choose 6 as a pivot for this subarray, right subarray. Now for the left subarray we are placing 1 such that left subarray for this array, this subarray again partition into subarrays. So place 1 such that left subarray is less than, see here, -3 -6 is less than 1 and 2 is greater than, this is right subarray. In the right portion again repeat the process. So place 6 such that left subarray contain the less than or equal to element and right subarray contain greater than element. So again repeat this process in the left and right. We are seeing here right subarray contain only one element, so do not further partition, this is not possible. So we must stop for right partition. Here we must stop for left partition, again division not possible, and for this one we partition this and for right we partition this. Now for this one -6 is pivot and for this 8 is pivot. So after choosing -6 as pivot, 6 before the -3, no left subarray possible, right subarray here and right subarray contain only one element, so there is no further partitioning. Here 8 place at its proper position and no left partition, only right partition and right partition contain only one element, so no further division. Now stop the process. All the elements are its proper position, see here all the data are changed in the original subarray, original array. So this is -3, then -6, then -3, then 1, then 2, then 3, then 5, then 8 and then 9. Means by this process, by this quick sort process, we are placed element in the sorted manner. This is sorted manner, all the elements are placed in sorted manner in ascending order. Now what is the algo says? Same scenario is written in the step by step. Now see the algorithm. So quick sort, just quick sort A is the array, this is P is the starting index of the array and this is R is the last index of the array. Now we are partitioning this array A with the starting index P, last index R, and after partitioning this will return the position of the pivot element, final position of the pivot element, and we are capturing this in the Q, means P, Q and R. Q is the position of the pivot element, and this is again we are same sorting quick sort apply with the left subarray. Now the left subarray having the starting index P, having the starting index P and last index as Q -1, because Q is pivot element here. Q, just see this is the first half array and again this is the second half, that is Q plus 1, one index after the this Q position and last index is R. We can recursively solve this sorting technique until P is less than R. This is the condition. P and R means P is the starting and R is the last index of the array. When starting index is less than the last index, then repeat this process. If they meets at the same point, means P equal R or R is less than P, then stop the process, stop the recursive process. Now see how to partition work. This partition, this is recursively called, no problem, and this partition algorithm. So first understand the partition, this is the fundamental of the quick sort. Now partition A, P, R. A is the array, P is the starting index, R is the last index. Now put the pivot element, means last element in the variable x, we can say. Now temporary variable or iteration variable I, we initialize I with the one less index than P starting index, one less than the starting index, and we are repeating j from P to R minus 1, one less than the last index. We will see one less than the R index, and if Aj is less than x, means pivot element, if the Aj is less than or equal to x, then what to do? We must increment the I and swap the element present at the position I and j. We will swap the elements, and after this iteration, after whole the iteration from P to R minus 1, now place the pivot element that is at the position AR. Place the pivot element at the I plus 1 location, with the help of swapping the element from I plus 1 and AR locations. Now return the I plus 1. Now final position of pivot is I plus 1. So now this is the C program of the quicksort algorithm. We are just convert this algorithm steps into the language, that is C here. So with the help of functions, this is the main function. We just initialize, for example, A7 means array, this is the element, fixed element. Okay. Now we call the quicksort for this particular array. Now 0, what is 0? 0 is the starting index, that is our array length is 7, so last index will be 6. 0 to 6 means total 7 elements, and after quicksort we will print the sorted element here. Now we will make two functions, one for quicksort and one for partition. Now quicksort receives the 3 parameter. Now here P is less than R. Repeat this process or recursive process repetition, P is less than R. Now partition APR, this will return the index, the Q, and we will recursively solve the from P to Q minus 1 means left partition, and from Q plus 1 to R, this is the right partition. Now partition algorithm, we convert the partition algorithm into coding. Same, what to do? We are receiving into the x, this is pivot element, last index R, last index we will make it copied into x, and I is starting index minus 1, and we repeat the j from P to, we repeat j from P to R minus 1, one index before the last index, and if we find the Aj element is less than or equal to x, then what to do? We simply increment the I and swap the element at the position I and j index, with the help of, here we are doing with the help of third variable, that is temp. So after coming out from this particular loop, that is for j, we are placing the pivot element at I plus 1 index, that is temp, with the help of temp, same funda, we are placing the I plus 1, we are keeping the I plus 1 element into temp variable, and then override I plus 1 with the help of last element, that is pivot element. Here we are placing the pivot element at its proper position, that is I plus 1, and we copy the temp value into the last position and return the I plus 1 location, that is the final position of the pivot. Okay. So for the first partition, this we get the Q, that is pivot element, and then recursively call for the left sub array. For the left sub array, same algo will call and check P is less than R, then again partition for the, now P is P and R become Q minus 1 position. R become, again partition will call and again this repetition process occurs. So after doing all the process, we get the sorted array, that is 2, 4, 7, 10, 13, 34 and 66. Now we can understand whole the scenario with the help of a example here. Same, just see what to do. Here this is the index of the array 0, 1, 2, 3, 4, 5 and 6. This is the starting index, that is P, indicated by P. This is the last index, that is indicated by R. Now our data was 34, 2, 66, 4, 7, 10 and 13. Okay. Now start the process. First partition this. So we have done, see here in the code, we are calling quicksort. Quicksort what does? First P is checked, P is less than R. Here, yes, P is less than R. P is less than R. So process start. What process? Partitioning APR. Now partition, what partition does? Simply last index into the variable x and I from starting minus 1. Now see here, this is the x variable, we can copy x equal AR, just AR means the element is 13. Now this is 13 and I initialize with the P minus 1, P indicated 0 means I is here. Now I is here and J start from where? Now J start from P and goes up to R minus 1. So we keep J start from P. This is the initial position. And now process start. What to do? Just check the element present at the J is less than equal to X or not. 34. Now element is 34. 34 is less than equal to 13. No, this condition become false. This element is greater than 13. So what to do? Greater than 13? Simply not to do this one. Simply increment the I, increment the J, means process goes further. Increment the J. Now J will come here. Now increment the J. Now J comes here. Again check it. This one, AJ position element is less than equal to X. Here 2 is less than equal to 13. Yes. Now condition become true. Then what to do? Simply just increment the I and swap the value presented at I and J location. Simply increment the I. Now I will come here. Increment the I and swap the element present at I and J location, means swap the element 34 and 2. Now 2 will come here and 34 will come here. We can erase or we can fill this cell with the red. This is red. Okay. Now our data is 234. Now what to do? We have done. Increment the J till R minus 1 and repeat the process. Now J comes here. Now element, compare the element and X value, that is 66 is greater than 13. So what to do? Simply increment the J, J come here. Now compare the element presented. 4 is less than 13. Okay, yes. Condition become true. Then what to do? Just swap the, just increment the I, first increment the I, I will come here indicating the index 1, and now swap the value present at I and present at j location. Now 4 will come here, and here the data is 34. We are seeing the larger element comes into the right side and lower element than pivot comes into the left side. We are in the process of partitioning. Now what to do? Simply increment the j. J will come here. Okay. Now compare this with the x element. J element is 7 and this is 13. 7 is less than 13. Then what to do? Simply increment the I. I will come here and swap the value present at the location I and j. Now 7 will come here. This is 7 and this is 66. Now what to do? Simply increment the j. Now increment the j. J is less than 1 position. Okay, j will come here. Now compare the element presented j and x. Now j is less than, j element is less than 13. So what to do? Simply increment the I. I will come here and swap the element present at location I and j. Now I is 34 and j location element 10. Now 10 will come here. Now 10 will come here and 34 will come here. 34. Okay. Now what to do? J loop exhausted. J loop start from starting position and goes up to r minus 1 position. Now if we increment the j, then this condition will false, then come outside the loop. Okay, after increment the j, so condition become false for this particular iteration and comes outside the loop, for loop j. Now what to do? Place the element present at I plus 1 location and r position. Okay. Now at the r position the element is 13, element that is pivot element, and place the pivot element at the position I plus 1. Now I is at the 3, so I plus 1 is 4th location. So swap this 66 and 13. Now 13 will come here. Now this is 13 and 66 will come here. This is 66. Okay. Now 66. Okay. Now this is our pivot element. This is our pivot element, and the right sub array element, left sub array element is, this is 2, this is 4, this is 7, this is 10, and right sub array element is 34 and this is 66. Now our original array partitioned into 2 sub array after placing the pivot element at the right position, that is 4th index. Now left sub array element are 2, 4, 7 and 10 that are less than the 13, and left sub array element are 34 and 66 that are greater than the 13, that is pivot element. Okay. So what to do now? Now repeat the whole process. Again for index from P to Q minus 1. Now position of Q is 4, written 4, Q minus 1 is this position 3. Now for repeat this process for this sub array, that is 2, 4, 7, 10. and after repeating find the element in the partition. Now for this one, for this subarray, this is P, this subarray, the P is this one, P is this one, and R is this one for the left subarray. Okay. Now repeat the process, and after repeating we find 10 as a pivot element. So just now for this iteration, this recursively call last element, that is X in this one, and for this again I 1 less than P. So I will indicate here and J will indicate at the position this one. J comes from here to this position, means for 0 index, 1 index and 2 index, and compare element for this one. So we will repeat this process again and again, and we find the same process for the left right subarray. In the right subarray, when we will consider right subarray, then P will here and R is this one and partition this one. So just after repeating the process, whole the process, we will find the sorted subarray, that are 2, 4, 7, 10, 13, 34 and 66. Okay. So in this manner we can sort the array using the quick sort. This is very effective sorting for the data. I think you have understand this. Okay, we have got sorted array. Thank you very much.